SOCAR Türkiye presenters new option, new topic, new special GE Vernova NPM. A special is the safety critical equipment management. Safety critical equipment management is we used to GE Vernova APM, customize, small and big customize. We started the startation. My name is Tamer Eldemir, Reliability Manager, SOCAR Türkiye, as you know, people. Okay, we start.
Thank you, Tamer Bey. Hi again, everyone. You're welcome to our presentation. We are SOCAR Türkiye, and we are going to presenting about safety critical equipment management and digitalization on RCA governance. I am Eymen. I'm working as a reliability chief engineer. I've been working on oil and gas sector 10 years. Berk and I will both presenting our implementations on GE APM. Here you can see Alea Peninsula, which is all our companies located here. Petchem is our petrochemical factories, Star Refinery, Petchem Res, which is wind turbine generation, SOCAR depolama storage, and SOCAR terminals. Petchem is the Turkey's first and only integrated petrochemical facility and having 3.6 million tons per year annually. Also, Petchem Res, which is Petchem wind power plant, has 51 megawatt capacity. Star Refinery. This refinery is known as the largest investment in a single point on Turkey. After our turnaround period, we increased our capacity to 13 million per year. SOCAR terminal, also we operate the terminal with annual capacity of 1.5 million per year TEUs. SOCAR storage terminals with 530,000 cubic meters oil and 45,000 cubic meters LPG storage. You are seeing all business units IMS scopes. Green highlighted is related about asset management system certification. Petchem and Star Refinery both get the ISO 55001 asset management systems. And today's topic, we are going to share about our APM and digitalization transformation journey briefly, then going with safety critical equipments management projects, and also RCA governance on digitalization. Here, our digital transformation journey, we separated into 3 phases. Everything started with gap analysis with STORC we performed in 2018. At 2018, project kicked off with GE Vernova, STORC, and SOCAR. We finished project around 2021, and currently we are trying to upgrade our systems and aiming to achieving maintenance excellence. Here, I give words to Berk for safety critical equipment.
Hi everybody, my name is Berk İşler. I'm the reliability lead engineer at SOCAR Türkiye, and I have over the 10 years experience in reliability engineering, both design and maintenance side in advanced tech and oil and gas industries. Today I will present you SOCAR Türkiye's safety critical journey. Before starting, I'm wondering how many of you heard about safety critical equipment? Please raise your hand. Okay, nice. And how we transformed classical maintenance management into the library management, I will tell you. Our main objective is very simple. Not only maintain equipment, but also continues to verify that our safety system is healthy, effective, and protecting our plant all the times. Because in process safety, biggest risk is the unknown, as you can see in the left hand side. The biggest risk barriers we think are healthy, but actually they are not. The project helped us move from the reactive maintenance management to proactive assurance approach, from the static records to live visibility, and from the isolated system to integrated systems. As SOCAR Türkiye, we wanted to a system where leadership can instantly see the barrier health, operation can understand the current risk exposure, and the maintenance team can prioritize their maintenance activity based on process safety impact. That become the foundation of zero ineffective barrier vision. Maybe you are familiar at this approach. This slide represents the philosophy behind the process safety. The process safety success depends on the three dimensions working together. One of the design integrity, the other one operating, and the other one technical integrity. If one of these fails, the barrier system weakens. You can design the best plant in the world, but if maintenance assurance is weak, probably you will face the major accident event at one time. Or you may maintain equipment perfectly, but the operating window is exceeded. Is still in the risk. So our project is focusing on the technical integrity as a hardware barrier management. Quick reminder, safety critical equipment project is more comprehensive than the SIS, Safety Integrated System. SIS is the part of the project, but we have covered lots of other barriers. Let's define what is the aim of the project. Preventing the major accident event. This is the core of logic, core of logic, our project. Our vision is very simple. If barriers are healthy, major accidents became preventable and manageable. To achieve that, first we need to identify hazards, accident scenarios, and the required barriers. Then we define which equipment acts as a barrier, what performance is expected, and how frequently we need to test them. This is the important shift here. We stop treating maintenance activities as a routine work orders. We turn into the assurance activities which prove the barrier is healthy. And there's a strong link between maintenance activity and the safety risk reduction. Let's move forward. Our target is very simple, zero ineffective barriers. What that means? The slides explain how the live barrier model operates. Have you heard about live barrier model before? Okay. We have three dimensions in the live barrier model. If you achieve the zero on all of them, you achieve zero ineffective barriers. To support this, we monitor preventive maintenance performance. I will explain later. Corrective maintenance impairments and overdue temporary MoCs on the SE items. Let's think that if preventive task becomes overdue, the barrier health degrades and it turns to unknowns. If corrective maintenance impacts safety functionality, the barrier becomes impaired. And if an overdue temporary bypass or MoC exits, unmanaged risk occurred. This is the triangle of our zero ineffective approach. We have three different pillars. First, identify. After that, you need to define the maintenance. And after that, track them all. let's look at the identification side. On the identification side, you need to define the barrier first. After that, you need to develop performance standard. It defines the boundaries, what do you need to do, assure the barrier, and after that, according to the boundaries, you need to identify your equipment and health check of your analysis performed very well. Maybe you are so familiar about the switches. Safety critical equipment is any equipment which can directly affect to the major accident event. You may already recognize the switches. If one of them fails, the other barrier protect you. But if every barriers fails at the same time, you may face the major accident event. The barrier definition on the IOGP start with the structural integrity and continue with the process boundary integrity and goes through the all other barriers like firefighting equipments, gas detection system, emergency response, emergency power, like that. You may think that we have already structured HAZOP, LOPA, and SIS system and we are safe. Probably you may be. You won't be safe because SC is more comprehensive than the SIS. And SIS, we use the SIS in our project, but the smallest part of the project. You need to define whole barriers as IOGP recommends. And three major important topics you should consider. The valid barrier must also effective, independent, and auditable. What that means, if the barrier must work when demanded, it's effective. It must not depend on another failed system. It's independent, and it must be periodically verified. It's auditable. And let's look at the performance standard development. Once barriers were defined, we created performance standards, and it includes barrier function, operating boundaries, assurance tasks, intervals, and acceptance criteria. This standardization was extremely important because it aligned process safety aspects, maintenance execution, and operational understanding. Now everybody can speak same language and everybody has same understanding on the process safety and safety critical equipment. When we have identified the SCEs, after that we need to record or register this SCE info somewhere else. So we use the SAP system as a master data, and we use the GE Vernova as a slave. But we don't have any special field for them. So internally, we have created new fields in the both system and mapped together, mapped them in. So you can see the criticality, barrier group, and performance standard when you look at the equipment card. Let's look at the result side. We have completed approximately over the 300,000 equipment, assessed them, and after that we defined the SCEs. But here is the important point. SCE ratios depends on hierarchy level. But important metric to benchmark ourselves, number of the performance standard required equipment ratio. it's aligned with the industry benchmark. So we are done at the identification site. Let's look at the maintenance site. I told you there's three main topic, and two of them is here. CM impaired and PMs with assurance task. On the CM, if you have impaired barrier, you need to raise maintenance notification. And in the maintenance notification, you need to define whether it's impaired or not. After impairment verified, the maintenance team should complete the maintenance activity within the 48 hours. So what happened if the maintenance couldn't complete within the 48 hours? You need to decide whether complete quickly or defer the maintenance activity and complete later. But during the deferment, you need to analyze the risk and take mitigation actions. If you choose the deferral and you got the deferred date, and reschedule again this task at the deferral date. Let's look at the data side. This slide explains live tracking capability. We added dedicated fields and tracking logic for the SE-related corrective maintenance activities, both in Meridium and GE Vernova. Also, new mappings have been done. Our one feature we found extremely effective was the traffic light system. This allowed teams immediately recognize healthy, degraded, or impaired barriers, and visual management significantly improved our response speed. On the other hand, we have created the new family to manage deferral process. If you couldn't maintain equipment within the 48 hours, you need to click the deferment link and trigger the deferrals process. On the PM side, more or less same logic like the CM. But here is the criteria. If a PM activity has assurance task, it should be completed at the due date. You couldn't allow the overdue item on this PM activities. So if you couldn't complete at that date, you need to start deferral process also. So how we can identify which PM task is assurance task or integrity task? There is a difference between them. Quickly, I will explain a little bit. Assurance task means that you prove the functionality of the equipment, whether it's working or not. Integrity task, like a replacement of oil or something else that, you need to change something but not prove the functionality. If you didn't do integrity task properly, you may end up with the functional failure, by the way. So in the SAP PM side, we have added some fields and improvements and mapped them to GE Vernova system. Also, we have integrity modules and the root modules in the Meridium. We record some assurance tasks in these modules. So how we can separate which one is assurance, which one integrity task? We have added new fields to separate them. But there is a problem. We have 3 different families, 3 different fields. So we need to merge all the 3 families in one. So we use the queries to build one vision. On the other hand, after project finished, data is okay. You have already checked the whole data, aligned with the performance standard, and you define the activity in SAP or the other system. But during the lifetime of the plant, somebody can change this data. One major challenge in large system is data integrity. So we developed automated validation logic on GE Vernova. The system continues to check whether every SE is connected to the correct PM activity. If one of them missing, you can directly find from here. And once data quality degrades, barrier visibility becomes unreliable. It turns into unknowns, as we said. Let's look at the auto follow-up side. While doing PM activities, you found something in the field. Normally, technician goes to the desk and opens the notification manually. But we have no tolerance of missing data. So we created the auto follow-up logic. In Meridium, if you record the PM activity as a failed, GE Vernova creates a recommendation, and after that it turns into the notification in the SAP system. This capability is one of the most impactful operations we have done. That ensures that failure recorded in SAP correctly. And let's look at the deferral side. As I said, we have created new families and new policies for managing the deferral. In our company, we have own deferral and MoC software developed by ourselves. But we need to use GE Vernova, and how can we start the deferral from there? So we created new family, and this family linked to the other third-party system via using the APIs-based sync. So you trigger from here, assess the risk in the other software, and the results come back to the Meridium. So we can achieve the full visibility and full traceability. Let's look at the track side. This is the important point of the project. Because if you don't track the results, you will fail. And we create some logic, and we call it as a live barrier model. You can see there is a two color coded. One is red and one is amber. Red means you don't have any tolerances. You need to see the 0 on these boxes. First one is the CM impaired. Second one, overdue PMs with assurance task. And the third one is the overdue temporary, as I said earlier. Amber ones is continuous improvement side. These not required to quick action, but if you won't sort it out in time, it will turn into the red. And here is some logic I briefly explain. If CM impaired couldn't sort it out within this 48 hours, it turns into the red. And if you start deferral, it turns to amber. Amber means there's a defect, I know it, and I can manage it. And for the PM activities, if overdue PM activity occurred, it turns into red, and if I start deferral, it turns to amber. And temporary MOCs is different topic. You change something on these SCA items. You know it, you manage the risk, and it comes with the amber one. And if temporary MOC's date exceeded, it turns into the red. You need to re-risk again, reassess again, or you need to close the MOC. This is the project timeline. We have wrapped up the project nowadays. It takes approximately 1.5 years, and it includes lots of different steps, including the cultural change, training, identification, and maintenance alignment. Over the last year, we have one KPI, 0 CM impaired item. And the second KPI is the 0 ineffective barriers, means that all of them should be 0. In 2025, the first column should be 0, but in 2026, all of them should be 0. These are some quick benchmark results. Our strongest way is we used GE Vernova as a based product. In the industry, there is an off-the-shelf product you can utilize these SCA logic, but we have developed ourselves in the GE Vernova. This is the strongest way we can take. During the project, we have developed lots of areas, SAP, Deferral, MoCs, and GE Vernova also. And we have invested over 5,000 man-hour in developing performance standards, data models, or training programs. It's a huge project, I think. And this is the Dada movement. We have achieved our KPI, first KPI, in the end of the 2025. It's the journey. In the beginning, we have lots of CM impaired items. We evaluated the backlog and assessed one by one. After that, we start evaluating at the time. During this journey, one important thing, while you're completing the maintenance activity, new impaired items have been risen. So totally, we have completed over the 800 work notification during this period. It's a huge effort and huge achievement, I think. Thank you for listening to me. I will hand over to the Ayman.
Thank you, Berk, and me again. I am going to present 2 features we implement by our own RCA governance system through GE APM capabilities. First one is RCA governance dashboard. Our main purpose for establishing this system transform RCA sessions activities into a structured and measurable governance view. Before this dashboard, like all users in same situation, I think, before this dashboard, it was difficult to clarity track how many RCA sessions were planned and completed and how much effort was spent, which disciplines were participating and not participating. The implementation starts by creating a new governance field in the RCA families. These fields were designed to capture structured information about RCA sessions. As the next step, we dedicated tabs was added under the definition section on RCA analysis modules. After that, the required fields were configured for session duration, attendance, and effort we spent. This is on the third step, by the way. Then the data was processed and converted into indicators and visual outputs on fourth step. Finally, all these outputs were consolidated on a single governance dashboard. This is part of our new dashboard. Now you will see the first one is monthly RCA sessions efficiency. And the second one is distribution of missing participation. It shows which management's equipments won't be attended. Here you can see the monthly completed sessions count, total man hours spent, and the total sessions durations. And finally, of our dashboards, we show us average man-hour effort per sessions and the data related to sessions history on the right side. In this slide, summarize the outcome of the RCA governance dashboard. Before the implementation, RCA sessions effort planned versus actual sessions and missing participations and recording status were difficult to track in one view. After this dashboard, this implementation, these points became transparent, measurable, and reviewable. As a result, the dashboard provides better visibility, stronger control, and improved quality continuity for RCA governance. Here, our second implementation on RCA governance system. We called it as a RCA recommendation escalation system. On this slide, you are seeing the evaluation of our recommendation track system. Initially, we managed our process manually, which means for each action, we filled in required fields within the recommendation alert tab provided by the system. On the second phase, we leveraged policy configurations to retire manually alert entries and activated an automated alerting mechanism on second phase. Today, I will explain you our third phase, which are fully automated, also hierarchical escalation notification system, and share impact it has delivered. I covered the system setup in 4 steps. First step is SAP data extraction. Second one is data structuring. Third, query-based hierarchical setup. And finally, the creation of the policy system, which is trigger all data. Start with SAP extraction. To build hierarchical structure within GE APM, we first needed to get data into system. To achieve this, we worked with our OT team to mapping each user's first manager from SAP through APM site. We use security management's user information screen for the mapping area. You can see how SAP data is reflecting in the comments field. In here, we took this data from SAP with mapping right in comment side. And the next, we processed the raw data bring into GE APM to correctly link each user's their first manager. We basically clarified the raw data to our database. And after transforming raw data, SAP data into structured rows containing each person and their first manager, we applied correct manual joins across the queries which full hierarchical model. You see, actually, what we made it here, we have two similar, which also same queries. We made a manual join to full name through first manager. Resulting fully dynamic data to mirrors SAP real-time and consolidated all required information in a one result set. You will see the hierarchical stairways, let's say. Then, as the final step, we used hierarchical data to build our action tracking system through a policy configuration. The system begins sending periodic reminder emails every 2 days before the 8 days of recommendations overdue, notifying both action owner and their first manager via mail. Once overdue, 3 additional reminders mails are sent at 2 days interval to recommendation owner and the first manager, still the first manager. In this time, also reliability team is included the mail traffic. After the third overdue reminder, the second manager is also included the escalation. Additionally, every overdue reminder clearly states which reminder number it is, with this providing full visibility to escalation stage. As you can see in the trend shown here, this chart presents the number of overdue RCA recommendations over time. Here, this time we activated the system. Within just 2 months of activating system, our overdue recommendations counts dropped by approximately 90%. Another significant outcome is that our overdue RCA recommendations trend has remained consistently stable since then. Beyond these numbers, the communication overhead, man hours, and man hours we previously spent chasing overdue actions have been effectively eliminated. It is also worth highlighting that this hierarchical structure we developed in GE APM is a reusable capability within GE APM and can be applied across other functional areas what we are doing on GE APM. That's all for the RCA governance digitalization implementation from us. Before the finalized presentation, I want to mention that we hold frequent meetings and trainings sessions to drive a reliability-driven cultural transformation. And also here you can see our global awards we achieved. Also our global presentations. That's all for us. Thank you.